This is the EdExcel GCSE 9 to 1 Maths Paper 3 from the June 2017 series, and this is a calculated paper. Question number 1. The table shows the length of 5 rivers, and for part A we have to write down the rivers in order of length. Start with the shortest river. Well, the shortest one is Don, 112 kilometers, then it's Mersey, 113 kilometers, then it's Trent, 297 kilometers, then it's Thames, 346 kilometers, then it's Severn, 354 kilometers. Next, for part B, Ami says the River Thames is more than 3 times as long as the River Don. For part B, we have to show that Ami is correct. Well, we've got the River Don, which is 112 kilometers, and if I times this by 3, I get 336 kilometers, and this is less than the 346 kilometers, which is River Thames, which means the River Thames is more than 3 times the River Don, so Ami is correct. Question number 2. Cups are sold in packs and in boxes. There are 12 cups in each pack. There are 18 cups in each box. Alison buys P packs of cups and B boxes of cups. We have to write down an expression in terms of P and B for the total number of cups Alison buys. Well, we've got an expression, so we don't have a formula, so we can't have T equals, and so we buy 12 cups in each pack and we buy P packs, so that means we would have 12 P cups in total, and from the packs, and adding on 18 times by B for the number of cups in boxes, so we have 12P plus 18B. Question number 3. Here are 4 digits, 5, 6, 1 and 9, and we have to write down the smallest possible 2-digit number that can be made with 2 of the digits. Well, the smallest number we can make, well, it will start with the 1, and then the next smallest one is 5, so 15 is the smallest 2-digit number we can make. Then for the next part we have to write down the 3-digit number that's closest to 200. Well, if I start off with the 1 as my first digit, that means I've got 100 and something. But then if I have 90 after it, well, that's quite close to 200, and then because the 6 is greater than the 5, the 196 is the 3-digit number closest to the 200 that we can make with those numbers. Question number 4. 4/5 of a number is 32, and we have to find the number. So if I let this number equal x, that would mean 4/5 of x is equal to 32. So if I times through by 5, 4x is equal to 32 times 5, which is 160. And if I divide through by 4 now, that means x is equal to 40. So the number we are thinking of is 40. Question number 5. A path is made of white tiles and grey tiles. 1/4 of the tiles are white. For part A we have to write down the ratio of white tiles to grey tiles. Well, if 1/4 of the tiles are white, that would mean 3/4 of the tiles are grey, and therefore the ratio of white tiles to grey tiles, we would have 1 to 3. So the ratio is 1 to 3. Then there are a total of 56 tiles. We have to work out the number of grey tiles. Well, we know that 3/4 of the tiles are grey. So if I work out 3/4 of 56, well, that's the same as 3/4 multiplied by 56, which is 42. So 42 of the tiles are grey. Question number 6. We've got a list of numbers here, and Bridget says to work out the median, you find the middle number, so the median of these middle numbers is 17. Bridget's answer is not correct. What's wrong with Bridget's number? Well, the middle number from this list, it is 17, but that won't be the median, because for us to work out the median, we'd have to put the numbers in order first. So, he did not put the numbers in order first, so that's what's wrong with his method. Now we have to work out the range. So, to work out the range, that's equal to the biggest number we have, which is 22. And then we subtract the smallest number we have, which is 12. Which means the range is equal to 10. For part C, we have to work out the median. Well, to work out the median, we need to find out the total of the numbers and divide it by how many numbers we have. So, the mean is equal to the total divided by n. So, if we add the numbers together, we've got 12 plus 15 plus 14 plus 17 plus 22 plus 19 plus 13, and we've got 1, 2, 3, 4, 5, 6, 7 numbers altogether. So if we work out what this is, we've got 12 plus 15 plus 14 plus 17 plus 22 plus 19 plus 13, and then we divide by 7, so it turns out we get 112 divided by 7, which is equal to 16. Question number 7. Pretty is going to have a meal. She can choose one starter and one main from the menu. So with starters we've got salad, fish and melon, and for main we've got pasta, rice and burger. We have to write down all the possible combinations that Pretty can choose. Well, we could have salad and pasta, salad and rice, or salad and burger. Or we could have fish and pasta, fish and rice, fish and then burger. Or we could have melon but pasta, melon, rice, melon, burger. Here are all the possible combinations. Question number 8. Joanne wants to buy a dishwasher. The dishwasher costs £372. Joanne will pay a deposit of £36. She will then pay the rest of the cost in 4 equal monthly payments. How much is each monthly payment? Well, the rest of the cost, well, I've got this £372 and then I take away the £36, which is my deposit, so I end up with £336. That's how much I need to pay. And what's happening is I'm paying £336 in 4 equal monthly payments. So, for the payment, we've got 336 divided by 4, which is equal to 84. Question number 9. Davos is a cleaner. The table shows information about the time it will take him to clean each of 4 rooms in a house. So we've got the kitchen, sitting room, bedroom and bathroom. Davos wants to clean all 4 rooms in one day. He will have breaks for a total time of 75 minutes. Davos is going to start cleaning at 9 AM. Will you finish cleaning by 4 PM? You must show how you get your answer. Well, we've got 9 AM, And then what we need to do is add on the 2 hours it takes to clean the kitchen. So the time he finishes cleaning the kitchen is 11 AM. So he's cleaned the kitchen. And then he needs to clean the sitting room. So we've got this 11 AM, but then we need to clean the sitting room, and to clean the sitting room, that takes 1 hour 40 minutes. So if I add on 1 hour 40 minutes, that means he would finish cleaning the sitting room at 12:40 PM. So we're at 12:40 PM, and then what we need to do is clean the bedrooms, and the bedrooms take 1.5 hours to clean. So I need to add on 1.5 hours to this, and it turns out we finished cleaning the bedrooms then at 2:10 PM. And then we're at 2:10 PM, and then we need to clean the bathroom, which takes 45 minutes. So the time we finish cleaning the bathroom will be 2:55 PM. So we're at 2:55 PM. But then what we need to do is clean, well, we've got our breaks as well, which we need to consider. So we've got the breaks for a total time of 75 minutes. So I need to add on 75 minutes, and it turns out we get 4:10 PM. So we finish after 4 o'clock. So we will not finish by 4 PM. Question number 10. ABC is a straight line, and the length AB is 5 times the length BC. AC is 90 centimeters. We have to work out the length of AB. So if we know that in total AC is 90 centimeters, and we know that AB is 5 times the length of BC, that means the ratio of A to B and BC, that will equal 5:1. And what we need to do is find out what AB is. Now in total, we've got 90 centimeters. So let's just move this here. Well, what we can do for anything else is draw a bar model. So we've got AB to BC being 5:1. In total, we've got 90 centimeters. So we've got 6 parts in total. 90 divided by 6 is 15. That means we've got 15 per part. So for AB, we've got 15 times 5, which is 75. And for BC, well, we've just got 15. So the length of AB is 75 centimeters. Question number 11. T is equal to 4v plus 3. We have to work out the value of t when v is 2. Well, when v is 2, t would equal 4 times by 2 plus 3. 8 plus 3 is 11. Next, we have to make v the subject of the formula t equals 4v plus 3. So, if I start off with t equals 4v plus 3, we want to get v by itself. First thing is we can subtract 3 from both sides, leaving us with 4v equals t minus 3. And then if we divide both sides by 4 to get v by itself, we will end up with v equals t minus 3 over 4. So we have v equals t minus 3 over 4. Question number 12. The diagram shows a cube of side length 2 centimeters. Vera says the volume of any solid made with 6 of these cubes is 48 centimeters cubed. Is Vera correct? You must show you're working. Well, first thing we can do is find out the volume of 1 cubed. So that's 2 times 2 times 2, 2 cubed in other words. So that's 8 centimeters cubed. And therefore, the volume of 6 cubes, we would have 6 times by 8, which is 48 centimeters cubed. And therefore, Vera is correct. And then for the next part of the question, we have to draw a cuboid that can be made with 6 of these cubes. Write down the dimensions of your cuboid on the diagram. Well, here is a cube and we need to add on the dimensions. So here we've got 2 times by 6, which is 12 centimeters. And then we've got this bit here, which is 2 centimeters. And then we've got the height, which is 2 centimeters. So now we have to work out the surface area. So for the surface area, well, I've got this 12 centimeters multiplied by this 2, but I've got that 4 times because it's wrapped around. So I've got 4 multiplied by 12 times by 2. And then I've got this front and back. Well, that's going to be 2 by 2. Well, I've got that twice. So I've got 2 times by 2 times by 2. And therefore we would end up with 104 centimeters squared. Question number 13. The size of the largest angle in a triangle is 4 times the size of the smallest angle. The other angle is 27 degrees less than the largest angle. We have to work out in degrees the size of each angle in the triangle. You must show you working. Well, what we have is the smallest angle equaling x. We don't know what it is. We know that the largest angle is 4 times the smallest, that's 4x. And the other angle, that is 27 less than the largest, so we've got the largest 4x, subtract 27. So now let's add up these angles and set it equal to 180. The reason we're doing that is angles in a triangle sum to 180. So we've got the x plus the 4x plus the 4x minus 27, which would equal 180. So we've got 9x minus 27 equals 180. If we add 27 to both sides, we would have 9x equals 207. And if we now divide both sides by 9, then we can conclude x is equal to 23. So knowing that x is 23, we can say the smallest angle is 23. The largest angle is 4 times by 23, which is equal to 92. And the other angle is 4 times by 23, subtract 27, 92 minus 27 is 65. So we've got our angles 23, 92, 65. Question number 14. Andy went on holiday to Canada. His flight cost a total of £1,500. Andy stayed for 14 nights. His hotel room cost $196 per night. Andy used Wi-Fi for 12 days. Wi-Fi cost $5 per day. The exchange rate was $1.90 to £1. You have to work out the total cost of flights, the hotel room and Wi-Fi. Give your answer in pounds. So we've got this conversion, dollars and pounds. Now to go from dollars to pounds, we would have to divide by 190, and pounds to dollars we would have to multiply by 190. So if we take a look at the hotel, we know that the hotel cost $196 per night, and we're staying for 14 nights. So 14 times by $196, if we work out what this is, we end up with $2,744. And now what we need to do using our conversion, we need to divide that by 190. So if I do 2744 divided by 190, then what we end up with to 2 decimal places is £1,444.21. So that's the hotel. We've also got the flight. Well, the flight, that's just given by £1,500. And then we've got the Wi-Fi. Well, Wi-Fi costs $5 per day, and we're using it for 12 days. So if I do 12 times by $5, that's $60. And to convert that into pounds, I need to do 60 divided by 190. So if I do that, we end up with, to 2 decimal places, £31.58. So what we need to do is find out the total in pounds. So I've got the hotel, 1444.21, the flight, 1500, the Wi-Fi 3158. So the total is equal to 2975.79. So we've got 2975.79. And for the next part, if there were fewer dollars to pounds, what effect would this have on the total cost in pounds of Andy's holiday? Well, what we're saying is there's fewer dollars to pounds. So now let's pretend that the conversion rate will be smaller. So for example, let's suppose it's something like 150 to £1. In this case, we divide by 150. So if I take a look at the hotel, for example, where I've got 2744, if I divide that by 150, what you can see is the price has increased in this situation. So if we have fewer dollars to pounds, well, we can say the price would increase. Question number 15, we've got a set of odd numbers less than 30. Here they are. And we've got A, which has a set 3, 9, 15, 21 and 27, and B, which has a set of numbers 5, 15 and 25. For part A, we have to complete the Venn diagram to represent this information. Well, first of all, what is common to both A and B? Well, what you can see is the 15 is common to both A and B. So we've got 15, which goes in A and B. So now let's cross off 15. Now, what goes in A only then? We've got the 3, the 9, the 21 and the 27 in A only. So we've got 3, 9, 21 and 27 in A only. And what goes in B only? We've got the 5 and the 25. So 5 and 25 go in B only. So now let's cross off what we have. We've got the 3, which is being used, the 9, the 21 and the 27. And we've also got the 5 and the 25. So now what remains are the rest of them. We've got 1, 7, 11, 13, 17, 19, 23 and 29. So what we've done here is used all the numbers. Then for part B, a number is chosen at random from this universal set. What's the probability that the number is in set A or B? So A or B, we've got 1, 2, 3, 4, 5, 6, 7 numbers. And we've got 15 numbers in total. So the probability is 7 over 15. Question number 16, we have to solve the simultaneous equations 3x plus y equals -4 and 3x minus 4y equals 6. Well, if I call this first equation 1 and this second equation 2, what we can do is subtract the equations. We've got the same number of x's with the same sign. So if I do equation 1, subtract equation 2, 3x minus 3x is 0x, y subtract negative 4y, that will be 5y, minus 4 subtract 6, that is minus 10. So that means y equals -2. We can now find out what x is. When y is -2, let's substitute this back into equation 1. We've got 3x minus 2 equals -4, add 2 to both sides. 3x is -2, which means x is equal to -2/3. So we've got solutions. x equals minus 2/3, y equals minus 2. Question number 17. The table shows information about the dress sizes of 25 women, and what we have to do for part A is find the median dress. Well, what we need to find first of all is the cumulative frequency. We start off with 2, 2 plus 9 is 11, plus 8 is 19, plus 6 is 25. So, to find the median, we need to do 25 plus 1 divided by 2, which is equal to 13. We want the 13th value. So the 13th value, that will lie over here somewhere. So the median would correspond to the 12th. Then, for the next part, 3 of the 25 women have a shoe size of 7. Zoe says if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 19/25, because 3/25 plus 6/25 is 9/25. Is Zoe correct? You must give a reason for your answer. Well, she's incorrect because events are not mutually exclusive, meaning they can happen at the same time. So that means a woman can have a dress size of 14 and a shoe size of 7. Question number 18. Daniel bakes 420 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. 2/7 of the cakes are vanilla cakes, 35% of the cakes are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5. What we have to do is work out the number of lemon cakes Daniel bakes. So, if we think about vanilla, what we have is 2/7 of 420. So we've got 2/7 of 420, which is 120. So we've got 120 vanilla cakes. If we think about how many banana cakes we'd have, well, we've got 35% of 420. So we can work out what this is using our calculator. We've got 35% of 420, which is 147. What we can do now is find out how many lemon and chocolate cakes we have. So for the number of lemon and chocolate, we've got 420 minus 120 minus 147. So we've got 153 lemon and chocolate. And now what we need to do is find out the number of lemon cakes we've got. And we've got this ratio 4 to 5. So we've got lemon and chocolate. And what we know is this total is 153. So we've got 9 parts in total. And if I do 153 divided by 9, we get 17. So that means we've got 17 per part, as we see here. So the total number of lemon then, we've got 17 times by 4, which is 68. And the total number of chocolate, that will be 17 times 5, which is 85. So the number of lemon cakes then is 68. Question number 19. In the diagram, A, B, B, C and C, D are 3 sides of a regular polygon P. We have to show that polygon P is a hexagon. You must show your working. Well, what we can do to begin with is find out the exterior angle of the square and also this 12-sided shape. So, if we were to find the exterior angle of a square, well, we've got 360 degrees divided by the number of sides, 4. So the exterior angle of a square is 90 degrees. So if I extend this line here, and this line here, and also extend here and here maybe, what you can see is the exterior angles are 90 degrees. Now what we can also do is find out the exterior angle of this 12-sided polygon. So the exterior angle of the 12-sided shape, well, 360 divided by the number of sides, 12, that's equal to 30. So now we can find the interior angle of P. Well, the interior angle of P will be this angle here, and notice that's the sum of the 90 and the 30. So the interior angle of P, that's equal to the 90 degrees plus the 30 degrees, which is equal to 120 degrees. So that angle here is 120 degrees. So what would the exterior angle be? Well, if I extend this line here, then the exterior angle of P, that will be equal to 180, subtract the interior angle of 120, which is equal to 60. So this angle here is 60 degrees, and therefore what we can do is find out the number of sides of P, that's equal to 360 divided by the exterior angle of 60, which is equal to 6. Now because we've got 6 sides, we've got P, which is a hexagon. Question number 20. The density of apple juice is 1.05 grams per centimeter cubed. The density of fruit syrup is 1.4 grams per centimeters cubed. The density of carbonated water is 0.99 grams per centimeter cubed. 25 centimeters cubed of apple juice are mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with a volume of 320 centimeters cubed. We have to work out the density of the drink to 2 decimal places. Well, what we'll do is we'll take a look at apple. What we can do is find out the mass of apple, the mass of fruit, and the mass of water. We know the total volume, and if we find out the total mass, we can divide those to find the density. So for apple, we've got 1.05 grams per centimeters cubed multiplied by the volume, 25 centimeters cubed. So the mass of apple then is equal to 26.25 grams. If we take a look at the fruit syrup, we would have 1.4, that's the density, multiplied by 15 centimeters cubed, which is the volume, so we get 21 grams of fruit. And if we take a look at the carbonated water, we've got 0.99 grams per centimeters cubed multiplied by 280 centimeters cubed, so we get 277.2 grams. So that's the total mass of water. So the total volume then we know is 320 centimeters cubed. The total mass, we've got 26.25 plus 21 plus 277.2, So it turns out we get 324.45 grams as a total mass. So the density is given by the total mass divided by the total volume. So we've got 324.5 grams divided by 320 centimeters cubed. So we get 1.01 grams per centimeters cubed. And that's given to 2 decimal places. Question number 21, we have to show that these two triangles are mathematically similar. Well, if I say that this angle here is x, such that this 10 centimeters is the adjacent, and then if I say that this is x, such that this 4 centimeters is the adjacent, well, matching up corresponding sides, this side matches up with this side would match up with this side, and this side would match up with this side. And what we can do is find out the scale factor in each of those cases. So if we think about this 12.5 and this 5, we could do 12.5 divided by 5, which is 2.5. That's our scale factor for this length. And what we need to check is if it matches up with the others. Now if I consider the 7.5 and the 3, well, doing 7.5 divided by 3, we get 2.5. And if we do the 10 divided by 4, we get 2.5. So what can we say from all this then? Well, what we can say is, because we've got this same scale factor of 2.5, we can say that the triangles are mathematically similar. Question number 2, for part A we have to complete the table of values for y equals 6 over x. Well, when x is 0.5, we've got 6 over 0.5, which is 12. When x is 1.5, 6 over 1.5 is 4. When x is equal to 3, we get y is 2. And when x is equal to 5, we've got 6 over 5, which is 1.2. And when x is 6, y will equal 6 over 6, which is 1. So now let's plot this. So we've got 0.512, that will go over here. Then we've got 1, 6, that goes over here. Then we've got 1.54, that goes here. Then we've got 2, 3, that would go here. Then we've got 3, 2, that would go here. Then we've got 4, 1.5. Well, let's just double check this value. When x is 1.5, y is 4, then when we've got 2, we've got 3, then we've got 3, 2, then we've got 4, 1.5. Well, 1 is over here and 1.5 would be in between those, and then 1.2 is over here, and 6, 1 is over here. So what we need to do is join these up with a smooth curve, such as the one we see here. Question number 23. Harley's house has a value of 160,000. Correct to 2 significant figures. For part A, we have to write down the least possible value of the house. Well, that will be 155 100,000, and then for the next part write down the greatest possible value of the house. That will be 165,000. Then for the next part, the value of Rita's house increased by 5%. A house then had a value of £210,000. We have to work out the value of Rita's house before the increase. So if it increases by 5%, that means the 105% would correspond to the £210,000. Now what we can do with this is find out what 1% is, and then find out what 100% is. So if we divide by 105, then 210,000 divided by 105 is 2,000. So we have 2,000, which is represented by 1%. And now if I times by 100, that means we end up with 200,000 for the value of the house before the increase. So we've got 200,000.